Hey guys, and welcome back. Today we are factoring quadratics. Hey guys, and welcome back. Franck here. If you're new, don't forget to subscribe so that you can get my videos the minute they come out. If you like this video, don't forget to hit the like button, share it with your friends, and you'll be helping me a lot. So today we're going to continue on factoring polynomials, but we're going to be focusing on factoring quadratics. Those are polynomials of degree 2. And so they are polynomials that are written in the form ax squared plus bx plus c. A cannot be 0, otherwise you jump back to a polynomial of degree 1. And c here is our constant. And so let's just jump into it, right? Let's just do the first example right now. The first example that I'm going to give you here is going to be 3x squared plus 5x. So this example comes in and shows you what to do if the constant is missing. It's still a quadratic because it's degree 2, but there's no constant. In this case, you can factor it very quickly because you look at this and you say, oh, those two terms have x in common. So you can actually pull an x out from both of them. So this 3x squared plus 5x can be rewritten as 3x times x plus 5x. And so since x is a common factor here, you can actually pull it out and put whatever is left in the big parentheses. So you're going to have x multiplied by 3x plus 5. Next example here, what happens when the middle term bx is missing? Then what you have is something like 4x squared minus 25. And because this is negative in the middle, you can look at this as a differences of squared. And if you remember from last time we talked about this, you can look at 4 as 2 squared, and so that's going to be 2x altogether squared minus 5 squared, because 5 squared is 25. And so since this is a difference of squared, you can actually write it as 2x minus 5 altogether multiplied by 2x plus 5. So let's move on to something that's to what we are really interested in. What happens when all three of those terms are there? In this case, you're going to have a trinomial, a quadratic with all its terms, right, of degree 2. And so for the first example here, let's give you x squared minus 10x plus 25. Now we can enter into a methodical way of solving these problems. We are going to look at this, and a here, the number a is going to be 1, the coefficient of x squared, and b is going to be negative 10, and then the constant here is going to be 25. And so what you should do, the first thing you should do here is to look for two numbers that adds up to negative 10, that adds up to b, and multiply to 25, meaning multiply to c. And so the easiest way to do this is to try to find the two numbers that multiply to 25 first, and then check if they also add up to negative 10. So if you look at 25 here, what two numbers can you think of? The most obvious one here is going to be 1 and 25, right? And so, of course, if you have that as the most obvious one, let's take its opposite, meaning negative 1, negative 25. That also works. And then the next one that we can think of here, that I can think of here, is 5 and 5. And then I'm going to take its opposite, negative 5 and negative 5. See, every time I find a pair, and I will always consider its opposite as well, because if you get a pair of numbers that multiplies to a number, their opposite also multiplies to the same number. And so from here, I can stop because I cannot think of any more pairs that will work and multiply to 25 here. So I'm going to start checking here to see which of these pairs add up to negative 10. So if I look at the first one here, it's going to be 1 and 25. If you add them together, you're going to get 26. That's not good. So that's out. And then negative 1 and negative 25 is going to give you negative 26. That's also out. 5 and 5 is going to give you 10. Close, but not negative. So that's out as well. And if I check the last one here, it's going to be negative 5 plus negative 5. That's going to give you negative 10. So this works. And so since that's our pair of numbers, you can then factor this polynomial of degree 2, this quadratic, as x minus 5 and x minus 5. See, so those 5 and 5 that you found here are the numbers that are going to go into the parentheses here to make this a perfect factor polynomial of degree 2. And then you're done with that one. Okay, if that one was a little bit fast, let's look at another one and let's see if we can do it again. So let's look at this one. This is x squared minus 2x minus 15. Again, our b here is going to be negative 2, our c is going to be negative 15, and our a is still just 1. And so we're going to find two numbers that add up to negative 2 and multiply to negative 15. And of course, the easiest way to do this is to start with the multiplication. So what are the two numbers that multiply to negative 15? Let's have a list on the side here. So the most obvious one always is going to be 1 and negative 15. And then its opposite, negative 1 and 15. And then we're going to have next one I can think of is 3 and negative 5. And then its opposite is going to be negative 3 and 5. And from there, that's it. I can't think of anything else. So now that we have that, let's check to see if we can find a pair here that will also add up to negative 2. And so the first one here is going to be 1, negative 15. That's going to be negative 14. That's out. The next one here is going to be negative 1 and 15. That's going to be 14. That's also out. Next is going to be 3 and negative 5, and that adds up to negative 2. So we found it. We found a pair that works. And so since you found a pair that works, you can just stop here. You don't have to check the rest of them. This is good. We're done. And so our factored polynomial here is going to be x plus 3 and x minus 5. And we are done. All right. So the two examples that I just gave here are very straightforward because a is just 1. What happens if a is not 1? So let's look at this next example here. We're going to have 6x squared minus 18x minus 60. As you can see here, a is 6, b is negative 18, and c, the constant, is negative 60. So what do you do when you have a that's different than 1? So what I would do usually is that I would look at this a and I would try to figure out if I can factor out a. If I can find 6 in every single term making up my polynomial, my quadratic, I can actually pull that a out. So in this case, 6 is good. Negative 18 can be written as 6 times 3, and then 60 here can be written as 6 times 10. So 6 can be found everywhere, so I can pull it out. So if I put a 6 here on the side, open my big parenthesis, I'm going to have x squared, and then if I take 6 from 18, it's going to be left 3. And then if I take 6 from 60 here, I'm going to be left with 10. Remember, we're dividing here. And so now what I have in the parentheses here looks just like the one that I had before, where the number in front of my x squared is 1. So I can just go back and do the same thing as before, where I can look for two numbers that add up to negative 3, and then multiply to negative 10. As usual, I will start by finding a number that multiply to negative 10, and start with the most obvious. It's going to be 1 and negative 10, and then its opposite, negative 1 and 10. And then I'm going to get as well 2 and negative 5, and its opposite, negative 2 and 5. And then that's about all the pair I can think of. Now let's go ahead and start checking to see if some of them work. So negative 1 and negative 10 doesn't work. Negative 1 and 10 doesn't work as well, doesn't add up to negative 3. 2 and negative 5 do work because that adds up to negative 3. And so I know this is my pair. And so this particular polynomial up here, quadratic, is going to be factored as 6 parenthesis x plus 2 parenthesis x minus 5. And then that's done. All right, let's look at the last example here and see what we have. 2x squared plus 5x minus 3. Now look at this one here. You have a, which is equal to 2, b is equal to 5, and c is equal to negative 3. Now in this particular case here, a cannot be factored out from this quadratic. So we can't do the method that we were doing before directly. We have to do something else, something in addition to doing just that. So there's a few things that are going to change here. You are still going to be looking for two numbers that are adding up to 5, but this time you're going to also look for two numbers that are multiplying to negative 6, because negative 6 is 2 times 3. So you look at A and C, you multiply them together, and then you will look for two numbers that multiplies to that result, -6. Then let's go back and do what we've been doing. So let's look for two numbers that multiplies to -6. Let's start with 1 and -6, and then its opposite, -1 and 6. And then we also have 2 and -3, and then its opposite, -2 and 3. And so now you can see that 1 and -6 add up to -5. So that's not 5, so that doesn't work. And then if you look at -1 and 6 here, that actually does work and adds up to 5. And so since we found our pair here, we're just going to ignore the rest of them because, well, if you find your pair, then you're done. So let me take some time here and erase these guys here. We don't need them. So because our A was not 1, we have to do something else here. We have to divide those two numbers that we just found by A. And so that's going to give us -1/2 and then 6/2. And then let's simplify it further completely. And so that's going to be staying -1/2. And this here can simplify to 3 and 1. And so now that we have our pair found and we divided by A, we can go ahead and factor our polynomial. So we're going to have parentheses and parentheses. This is going to be very, very important. The number that you have on the denominator here, 2 and 1, those are going to go in front of the x's. So you're going to have 2x here and 1x here. And then the numbers on top, -1 and 3, are going to go on the side. So you're going to have 2x minus 1 here and 1x plus 3 here. And that's it, right? And so whenever A is not 1, you cannot directly go into the method that we've been doing. You have to pay attention to that A. And so you are still looking for two numbers that are adding up to B, but you're going to be looking for two numbers that also multiplies to A times C. In this case, -6. And then once you find those two numbers, you have to divide them by A again, simplify it a little bit so that you can reduce them completely. Then you can write out your solution using the denominator as the coefficients of x and the numerators as the constant in your parentheses. And then this will be it. Our very last thing that I want to talk about today is notice that every single quadratic that I've given you here have been able to be factored, but that's not always the case. And so let's look at this one here. If I gave you x squared plus 8x plus 20, and I wanted you to factor this is not actually factorable, if that's a word. You cannot factor this particular quadratic. And the reason why I know that is because this quantity, b squared minus 4ac, is negative. So whenever b squared minus 4ac is negative, then this quadratic is called a prime trinomial. And so if I just checked it very quickly here, b squared minus 4ac is going to be 8 squared minus 4 times 1 times 20. That's going to be 64 minus 80. That's going to be 16 negative. And so that's going to be prime because this quantity is negative, right? And so whenever you're given a quadratic, if you don't want to jump directly into it to try to figure out what the factors are, you can actually just quickly just do a b squared minus 4ac on the side of it. And if that quantity is positive, then great. That means you can actually go ahead and try to figure out what the factors are. But if this quantity is negative, don't even start trying because it's impossible to do it. And so you shouldn't do it. That would be a waste of time. All right, guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.